Today we are continuing with the introduction into 3D printing. Extruder categories and subcategories. Extruders are confused with the 3D printing heads, but the actual extruder is the gear assemblies that push the filament forward or backwards. But sometimes the word extruder is used for the entire 3D printing head, including the hot end and stepper motor. The extruders are where most problems happen, and they are the most delicate and time-consuming to troubleshoot. Therefore, there are a few categories and subcategories of extruders and subassemblies. There are direct extruders and Bowden extruders. A Bowden extruder separates the hot end, depositing the hot plastic from the stepper motor, which is fixed but pushes the filament through a Bowden tube, PTFE, or Capricorn. Capricorn brand tube is better. The advantage of the Bowden extruder is the fact that it has less mass and it can move a little faster on a Core XY or a Cartesian 3D printer and faster still on a Delta printer. The disadvantage is the stringing and the retraction settings need to be larger to alleviate the stringing. In the Bowden extruder, the stepper motor does more work and gets hot. An active fan and heatsink may be necessary. The direct extruder carries the stepper motor with the hot end and therefore a lower speed is required. I think the trade-off is negligible because it removes quite a few problems. If the stepper motor is heavy, then the extruder itself needs to cruise at lower speeds to alleviate with 3D printing artifacts. A subcategory of the extruder are the dual gear or single gear extruder mechanisms. Both can be any of the direct extruder or the Bowden extruder, but dual gears pushing the filament are more reliable than single gear with an idle pulley, because the filament gets to slip and you get under extrusion and ugly walls or complete failed 3D prints. It doesn't take much for a 3D print to fail. There are a lot of hot end styles and clones available. The most common are the all metal hot ends and the rest. It is improper to call them all metal because all hot ends are metal made. The difference is in the heat break throat that connects the heating block to the heatsink. Hot ends are composed of a few parts. The nozzle, and the most common, is the 0.4 mm wide nozzle. Heat block holds the thermistor that heats up the block and the nozzle. The heat break throats connects the heat block with the heatsink and allows the filament to flow through all the way to the nozzle. And then you have the Bowden tube that slides into the heatsink all the way to the nozzle through the heat break, or only touches the heat break, never reaching the hot area next to the nozzle. The difference is the heat break throat for all metal hot ends versus the rest. There are two types of heat breaks, one that allows the Bowden tube to slide in and touch the nozzle through the heat block, and the PTFE Bowden tube must be flush with the nozzle, creating a seal to prevent the molten filament from spilling. And if the seal is not properly formed, then eventually you will get retraction problems, stringing and filament changing problems. A blob will be formed larger than the diameter of the Bowden tube. In this setup, the PTFE Bowden tube is exposed to high temperatures and eventually breaks down and needs replacement. And the other is the all metal heat break that only allows the filament through, and the Bowden tube only touches the heat break throat, never reaching down in the hot area, thus lasting for a longer time. But these cannot handle long retractions and mostly demand a direct extruder. The PTFE Bowden tube allows a more frictionless filament traversal, whereas the all metal heat break throats may cause some friction. And a longer retraction could clog the heat break because molten filament can get in a cold area and harden. Some use an oil paper towel in the filament path to reduce friction. Multi-materials, options, and add-ons. There are a few options for multi-materials. The Prusa MMU, which clearly works with the Prusa 3D printers. Then you have the Mosaic device, which takes 4 filaments and adds them together in one single wire to be extruded. Then you have the Tool Changer, which is still only a prototype, and maybe some other companies may come out with similar versions. Then you have the multi-material extruders 3D printers, and you also have the M3D multi-material that takes 4 filaments, but it combines them. Not sure if you can match each filament with each color in the slicer with that extruder, but you need Mesh Mixer or other software to print multicolor or multi-material. This becomes more complicated, but work is being done to solve those problems. Support in 3D printing, communities, and help. When you do your research, you can find a lot of help on Reddit, Facebook groups, YouTube, forums and blogs, and 3D printing dedicated websites and the like. Getting parts and tools. Getting parts and tools happen after research, and most of the time parts come from Amazon, eBay, and Chinese websites like GearBest and Banggood and AliExpress. But the exceptional parts need to be researched and mostly are sold in specialized 3D printing websites which do not sell in volume. Stepper motors. There are a few types of stepper motors that can be used in your 3D printer, but they're all known as NEMA 17 stepper motors. Some may use larger sizes for open builds or proprietary 3D printer designs. Then you have the closed loop stepper motors that are designed to never skip steps. They have additional electronics and hardware to make sure that the steps are not skipped. They are more expensive and sometimes unaffordable. In addition, you have thicker or thinner motors that can drive more or less torque in ounces or Newton meters. And then you have the 1.8 arc per step and the 0.9 arc per step. In addition to those, you have the 2-phase stepper motors and then the 5-phase stepper motors. The 0.9 arc steppers are more precise, but they do not come with most 3D printers, so you have to change the firmware or the G code for your 3D prints to use those steppers. 3D printer motherboards. The motherboards are where the G code is interpreted and sent to the steppers, but the stepper controller chips are also very important, as sometimes the stepper controllers are more expensive than a cheap motherboard. There are two types of motherboards: motherboards with soldered stepper motor controllers, or the ones that have stepper controller sockets onto which you can change the stepper controllers. You must research which kind of motherboards your 3D printer may come equipped with before you buy it, because the cheap 3D printers come with the stepper controllers that you may want to change at a later time. But you can always buy a better motherboard or a quiet motherboard for your 3D printer. Stepper motor controllers. The stepper controllers get expensive. They can run you about $60, but sometimes the quality of the prints and the quietness of the stepper motors are worth it. In addition, not all motherboards can properly integrate all stepper motor controllers. This is a very advanced topic to pair motherboards with motor controllers for the first time. It is best to stick with what the community has tested and gotten good results with. Check for Trinamic 2208 or 2130 stepper motor controllers. Power supplies. The best option is to get a 3D printer with a 24-volt power supply. Meanwhile seems to be accepted as a good brand, but it needs to be able to output about 30 or 40 amps, or otherwise the bed heating will suffer and or maybe your actual look on your 3D prints. JST connectors. If you start upgrading your 3D printer, eventually you will need to know the JST connectors your 3D printer motherboard uses, or the pitch, so you can crimp and solder the JST connectors. Wires and crimpers. If you need to crimp JST connectors and wires, you need special crimpers. Your regular needle nose pliers won't do it. Try the Engineer crimper from 1 to 1.9 millimeters, or try the IWS-3220 micro connector pin crimping tool. Firmware updates, firmware compiling, and names. You have the Marling firmware, the Repetier firmware, RepRap firmware, SmoothieWare, Teacup, Clipper, and Redeem. You can find precompiled firmware on GitHub, but if you need more specific settings, you need to compile it yourself. You need the Arduino compiler and editor to modify and compile firmware according to your needs, but just research, because sometimes you can include an override code in your G-code file of your object to print, thus not being necessary to modify your firmware. In addition, you can use Octoprint, which is more flexible, but you need to attach the 3D printer to a computer or a Raspberry Pi. VREF and multimeter. VREF. When you change the stepper motor controllers, you must change the VREF, and for that you need a multimeter to measure the voltage. Also, when you have weak stepper motors, you may want to check the VREF. And it is recommended that checking the VREF is part of your workflow for any new 3D printer assembly and installation. 3D printer rails. You have the V-slot rails with rollers. Aluminum extrusions. 2020 means 20 by 20 millimeters extrusion, so 2040 is 20 by 40 millimeters extrusion. And linear rails. H-linear rails come in diverse qualities, but the coveted brand is High-Win. Linear rails are from steel or hardened metal, and they are usually installed on V-slot rails or other type of metal. The consensus is that linear rails are better and more precise, therefore more expensive. Then you have rod-like linear rails. Linear rails eliminate the need for eccentric knots with rollers and the pressure tuning of those rollers to a happy medium. Timing belts, gears, and pulleys, idling pulleys. 3D printers come as a combination of timing belts, geared pulleys, idling pulleys, and lead screws. There are very few 3D printers that use exclusively lead screws rather than belts. The most common belt is the GT2 belt, and the number 2 stands for the 2mm pitch of the geared belt. Not all belts are the same quality. Some cheaper ones may stretch and it will mess up your 3D prints. 3D printers, pliers, and cutters. You will need wire strippers and cutting pliers and needle nose pliers to finish up your 3D printed models, to remove supports, and to tune, upgrade, and fix your 3D printer. Zuron pliers. If you need more of the nippers your 3D printer may have come with, then get the Zuron nippers or Kevlar scissors. Made in America, baby. Heat guns. You may need a heat gun to remove your 3D print strings, or a rework station, soldering station. A soldering iron is good for soldering wires when you're upgrading your 3D printer or the wires break. Lead screws. Most of the 3D printers have lead screws, but some use ball bearing screws which are better and more precise. 3D printer calibration. Bed leveling is a vital process without which the 3D printing process doesn't start. However, there are other fine-tuning calibration options that can get you better results or accurate dimensions on your 3D prints. One of them is to calibrate the filament extruder. Remote 3D printing and monitoring. You can use Octoprint or Repetier host to monitor your 3D prints and cancel them if they fail. In addition, it is wise to have some sort of alarms to prevent fires if something goes wrong with your 3D printer and starts a fire. There are methods to prevent your 3D printer from being able to fail into a fire through temperature runaway protection. 3D printer starter kit. And finally, if you buy your first 3D printer, you'll need a 3D printer starter kit to attach upgrades you 3D print or upgrade parts of your 3D printer. The most vitals are nuts and bolts, millimetric M3, M4, M5, and T-slot M3, M4, and M5 for V-slot rails. Most 3D printers come with a bare minimum of Allen keys, so you can use those, but an iFixit kit may be better suited. Bowden hot end valves or push fit connectors or vacuum valves. Storage and organization. You have small parts, large parts, and tools. Also, you have a lot of 3D printed parts and tests that you may need to organize after certain changes in your workflow. Testing your 3D printer. Testing your 3D printer is part of the calibration process, but there are very many methods of testing your 3D printer. The most common tests are the 20mm cube and the lattice stress test. And you can get those to print with minimal tuning, but if you want fine precision, then you need a combination of fine-tuning your slicer settings for precision and calibrating your E-steps on your stepper motor, especially on the extruder. You also have the 100mm stepper motor calibration test. And printing a plethora of 3D objects designed to expose certain problems or capabilities your 3D printer may or may not be able to handle. Stay tuned for the next videos as we dive deeper into each of the introduced topics.